Greetings. Welcome. I didn't see you there. I was just looking at page 628, problem 21, talking about circles like I always do. And you happen to stumble upon a wonderful little opportunity to learn about them. So, welcome. Join me. So let's see. I want to write this in standard form for the equation of a circle and graph it. Currently, it's actually not even in general form. This is in like some weird hybrid form. So standard form, I might as well write it out for us. That has an R in it. Is the following: x minus h squared, let's see, plus y minus k squared equals r squared. And it's directly derived from the distance formula. And a couple facts: the center is at h comma k, and the radius is r. Radius is r. Maybe I was saying r and wrote r as I said it. That's probably what happened. So in this case, I want to rearrange my formula to make it look like that. Let me actually rewrite this formula as it is. 36 minus x squared equals y squared. So I want the x's and y's on the same side, and then my constant on the other is my plan. So I'm going to add x squared to both sides. And actually, while I do it, I'm going to kind of flipperoo the whole thing anyway. X squared plus y squared equals 36. All right. And what I want to point out is that I technically do have this in standard form. This is the sufficient way to write it. But let me just rewrite it like this for sake of some, super clarity on what's going on here. All right, so if you kind of imagine this situation, it might be more obvious when I ask, for instance, what is the center of this circle? Anyone have any guesses? 0, 0, right? So it's centered at the origin, and the radius of said circle is going to be 6. Perfect. Right? So let me actually, I'm just going to set up a grid here that I can steal snapshots from, just so I can more easily graph this. Let's see. And I will display color. Okay, so let me get a snapshot of this. And paste it over here. No, did I? No, nope. There we go. There, just so I've got a grid a little bit better. So, in order to graph this, what I would do is first plot the center. So 0, 0, right at the origin, the origami. Then I would plot 4 points using the radius as my distance. So I would be all like, I don't know, maybe north, south, east, west, up, down, left, right is a pretty good place to start. So I'll go up 6 units from the center. I'll go right 6 units from the center. I'll go down 6 units and left 6 units. And then when drawing this by hand, I would usually draw just kind of like one quadrant of it at a time. So I'll do like that and then that. But I have a circle tool, which I guess you guys could have a circle tool too if you bought like a cool Trapper Keeper before school this year, and maybe like it had a compass and like a protractor in it, and that would be pretty cool. So so here's our circle, and that's pretty much it. I mean, you can see the radius is the length of 6, and in fact, any way I go out is going to be 6 units. All right, so all of these points, it's the locus of all points that are equidistant in a plane from the fixed point, the center. Right? Good stuff. So that's our basic problem, warming us up. And now look at 25. Wow, this one's crazy. Wow, craziness. So let's see. Man, I was just having like all sorts of flashbacks of, saying this guy's crazy. In the Legend of, with Zelda 64, Ocarina of Time, there's a dude, and you're all like planning on busting into the castle to save the princess, and the guy's all like, "This guy's crazy. He's gonna bust into the castle." And what's even funnier is like the way the dude dances. He dances almost like a marionette, and he's all like, "This guy's crazy," and it seems like he's the crazy guy, really. But you do end up saving the princess, apparently. So, anyways, that was worth it. But anyways, I'm sorry, I just get distracted. But this problem, nonetheless, is crazy. Just like that. The first thing I might do is realize, first of all, this is going to be a circle. The reason is because I've got an x squared and a y squared term, and both of their coefficients are equal, like superly equal, all right? Very much the same. I do want those coefficients to be 1s, though. So what I'm going to do here for 6x squared, I'm just rewriting it, minus 12x plus 6y squared plus 36y equals 36. First thing I'm going to do is divide everything by whatever those coefficients are, just to get them to equal 1. And everybody gets divided by 6. And that'll make this guy a little less crazy. So let's see, this will be x squared minus 2x blank, foreshadowing, that's what that is, plus y squared plus 6y blank, another bit of foreshadowing there, equals 6 blank blank. All right, so I've set myself up for a nice little situation here because I am going to double complete the square. I'm going to complete the square for the x's and I'm going to complete the square for the y guys. So to complete the square, the trick to finding your new c term was, well, actually I'll write it down. New c is equal to b over 2 all squared. All right, b was the coefficient of your linear term, right? So in that case, it'd be the, well, negative 2, I guess. And in completing the square, I'm going to use the following pattern, that a squared plus 2ab plus b squared is equal to a plus b all squared. So those are the two facts that you had to know coming into this situation. And if that was a minus sign, then this is a minus sign. So let's find our new c term. So for the x's, the new c term is going to be negative 2 divided by 2 all squared, which is negative 1 all squared, which is positive 1. So I'm going to add a 1 here. However, if I'm adding a 1 there, I can't just do that willy-nilly. I got to make sure I do the same thing to both sides of the equal sign, right? Maintain equality. So I'm going to add 1 to both sides. For the y's, let's find its new c term. 6 divided by 2 all squared equals 3 squared equals 9. And so now I'm going to add a 9 here and add a 9 there. Okay? So we can now factor x squared minus 2x plus 1 using the pattern. The a was equal to x. The b is equal to, I guess, well, 1 or negative 1, depending on what you want to think about it as. So it factors to be what all squared? It'll be a minus b, or x minus 1 all squared. The thing I like to look at for that minus 1 is whatever you had right before you squared it will be that minus 1. It's also going to be half of the b term, which is actually where that number came from. And it's going to be the square root of your c term right there, as long as you're taking into account this sign. So there's like 3 ways you can figure out what goes there, which is kind of nice. Let's see, then I've got a plus sign, and then I'll have what all squared. So that'll be y and plus 3, that's a positive 3. Equals, and that looks like 16. And that is standard form if I've ever seen it. And let's gather some information from this, just like back in the days of y equals mx plus b. X plus b. You could figure out the slope and the y-intercept merely by looking at the equation. You immediately knew the facts about it. And similarly, in this form, I can just look at this, look at it, and just figure out what the center and radius is. So what is the center here, friends? 1 and negative 3. So big clue there, big hint It is the opposite of these numbers. Opposite. All right? And the radius
4.
is 4. It's the square root of that number because remember, standard form is equal to r squared. So just like how this, right, bam, bam, right, good stuff. So there's my radius. And now let's give this a graph. Let's see, center, negative 1, 3. I think I'll have, let's see, 1, negative 3. Man, I keep dyslexifying stuff funnily. Let's see. I think I've given myself, I think this is about where my quadrant needs to be focused. So let's plot some points. The center is at over 1, down 3. Something there. And the radius is 4. So from this point, I'm going to go up 4. Ah, man, I'm full of the mistakes today, but I've got friends. And what does one do if they stumble when they're alone? But 2 are stronger than 1. Am I right? So you guys help me out. No, wait. That's not 4. Bam. It didn't feel like a circle after putting that point. I can tell you that much. So I just go up 4, right 4, down 4, left 4. And let's use my handy-dandy circle tool, which is defined by center and radius, oddly enough. Well, actually, I guess this is almost more of an elliptical tool, since I can make ellipses. Ellipses? Yeah. So, so there's our circle. Man, wonderful. Fortunately, I don't require us to find out what the X-intercepts or Y-intercepts are, but you could. Actually, that does sound kind of interesting. If you wanted to, you could actually just, if I wanted to find the X-intercepts here, I would just set y equal to 0, and then I'd have a quadratic equation to solve, and there'd be 2 answers, because notice there are 2 answers. There's bam, X-intercept, and bam, X-intercept. How great is that? So, thanks for watching, Internet friends. Consider yourselves smarter. Bye-bye.